Alright, today's topic is add and subtract rational expressions. When we add and subtract rational expressions with like denominators, what we're actually doing is adding or subtracting the numerators, and we write that sum or difference over the common denominator. You can see in example 1 that these denominators are exactly the same. Therefore, the final answer is going to have that same quantity of x plus 1 in the denominator. What we're actually doing for this problem is adding. So we have this quantity of x squared plus 3 added to 5x squared minus 2. So that looks like x squared plus 3 added to 5x squared minus 2. If you have any common terms or like terms in this numerator, they need to be combined. And I can see that I have some terms with x squared, and then I have some constant terms that need to be combined. So the first set of like terms I have is 1x squared, positive 5x squared. That's going to make 6x squared. 3 take away 2 would be plus 1. In our denominator, we still have that quantity of x plus 1. That was our common denominator. And this is our final answer because 6x squared plus 1 doesn't have any factoring possible for us to reduce. So there's our answer. In example 2, again, to add or subtract, we're looking at our denominators. We have a common denominator already, so we know that whatever's going to happen in that numerator, our denominator will remain x plus 2. In this example, it is subtraction. So this is where we have to slow down. Anytime you have subtraction, that negative has to be distributed to any of the terms coming after it. So you might prefer to put a set of parentheses around all the terms coming after that minus sign. So our first term of x squared will remain x squared. Subtraction of 4 would be minus 4. So what we're left with is a binomial that is x squared minus 4. Do you recall from some past lessons that this is actually a difference of squares? So this numerator can be factored. We know that the quantity of x plus 2 times the quantity of x minus 2 is how that difference of squares factors. We do have our denominator still of x plus 2. Now, do you see any reason why we would need to think about factoring? Well, quantity of x plus 2 is in common. Therefore, we can reduce the answer. Since everything is collected in the numerator, quantity of x minus 2 is the final answer. Now, we aren't always going to have the luxury of a common denominator, so we have to figure out how to come up with the lowest common denominator. So here are some tips. We're going to factor each denominator completely. The lowest common denominator is the product of all unique factors raised to their highest powers. So we're going to practice determining the LCD, and then we're going to add and subtract with unlike denominators. You can see that x plus 1, 3x plus 3, and 2x plus 2 are not exactly the same. So if we can factor any of these denominators, that's what our first step should be. X plus 1 is already factored, but 3x plus 3 has a common factor of 3 and quantity x plus 1. 2x plus 2 has a common factor of 2 and another factor of x plus 1. So to create our lowest common denominator, we're looking for unique factors. So I know that this quantity of x plus 1 is part of the LCD. Do you notice how that is found in every one of these denominators? And it's written exactly the same way each time. All of those quantities are written to power of 1. So the other factors that are unique would be factor of 3 and factor of 2. So I include 2 times 3 times the quantity. If you want to call 2 times 3 6 times quantity x plus 1, that's perfectly fine. Now that we know what the lowest common denominator is, every term here needs to be rewritten so that the denominator is 6 times the quantity of x plus 1. So we're going to start with our very first term here, 2 divided by quantity x plus 1, and compare that denominator with our LCD. Well, we can see we've got the quantity, but we don't have 6. So we're using the building up technique. That means you're multiplying the numerator and denominator by the factor that's missing. Okay, so now we have quantity x plus 1 times 6, and that matches exactly with the LCD. Next, we've got a minus sign. That's always trouble. So what I recommend is that you use a bracket to come after that. So no matter what we write inside, we will remember to distribute that negative to whatever is inside the parenthesis later on. So I'm starting with 3x over 3 times quantity x plus 1. So keep it in its factored form. Does 3 times that quantity match the LCD? It looks like we need to build up with a factor of 2. Close the parenthesis. So if I took 3 times 2, I'd get 6 times quantity x plus 1. That matches exactly. Last, we've got a plus sign, so no worries with plus. We're starting with 1 over 2 times quantity x plus 1. This denominator does not match the LCD. It's missing a factor of 3, so we use 3 to build it up. Now what you should notice about all 3 denominators is they should all be 6 times quantity x plus 1. And sure enough, they are. So we have built up everything correctly. And what that translates as is 6 times the quantity of x plus 1 in our denominator. Let's go back to the first term. 2 times 6 would be 12. So I'm simplifying that as 12. Inside the bracket, 3x times 2 makes 6x. However, we have this minus out in front, which tells us multiply negative by whatever is in the bracket. So that translates as minus 6x. So that's typically where mistakes occur, so you really want to watch out for subtraction. Last, 1 times 3. This is being added, so that's the addition of 3. Now what you might notice is sometimes we have like terms that get created. So what we end up with is 15 minus 6x divided by our common denominator. You could also write minus 6x plus 15, but it tends to be easier if you don't start out with a lead term that's negative. So our common factor would be 3, leaving 5 minus 2x. Our denominator is 6 times quantity x plus 1. So we actually can reduce something here. 6 is the same as 2 times 3, so we have a factor of 3 that's in common. These quantities are not identical though, so they are not going to reduce. We have 5 minus 2x in the numerator and 2 multiplied by the quantity for the denominator. So there's our final answer. If you choose to distribute, it's also acceptable to write 5 minus 2x over 2x plus 2. But we tend to like the factored form because it definitely reveals if any more reducing could be done. For example, 4. Again, we have unlike denominators, x squared plus x minus 12 and x plus 4. So it looks like x plus 4 is factored already. So this trinomial needs to have some factoring. Do you think maybe x plus 4 might be one of the factors? Let's try that out. If that's true, then the only way to get x squared for this term would be to have x multiplied by x. How could we create negative 12? Something times 4. Well, that would be negative 3. So the only thing we'd have to check now is to make sure that the inside of minus 3x and outside product of 4x, that makes positive x. That works. So sometimes you won't have to do sum and product and all the grouping. Use the term that's already given as a hint. It doesn't always work, but it's sure nice when it does. All right, so our lowest common denominator has factors of x minus 3 and quantity x plus 4. Those are the unique factors, so we need them both. So we'll start with 6x minus 11 over its denominator in factored form. This denominator already matches the LCD, so it does not need any building up. Since it's a subtraction problem, remember, I highly recommend you use a bracket coming after that. 5 over quantity x plus 4 was given, and notice how this quantity of x plus 4 does not match the LCD. What do we need to build it up with? Quantity x minus 3. Right, that's the one that's missing. Okay, so now we can see that both of our rational expressions have exactly the same denominator, and that is quantity x plus 4 times quantity x minus 3. Doesn't matter what order you write those in, as long as you have each one. Now let's see what is remaining in our numerator. 6x minus 11, we just copy. Inside the bracket is where you start. 5 times x is 5x. 5 times minus 3 is minus 15. However, we have a minus out here, so we have to distribute that negative to each term. That is minus 5x plus 15. So do you see what I've done here? Negative times 5x is minus 5x, and negative times negative makes plus 15. Again, that's where most people make the mistake in this problem. So don't be one of those people. Be careful here. Now, 6x minus 5x, that's going to leave x. Negative 11 plus 15, that's plus 4. In our denominator, we had quantity x plus 4 times quantity x minus 3. So do you see how helpful that is? Quantity of x plus 4 is reduced. It doesn't just disappear. Remember, when you have something divided by itself, what does it really equal? 1 over 1. So our final answer, there is a term of 1 in the numerator and quantity of x minus 3 in the denominator. So we do have a fraction or a rational expression for the final answer here. So do be careful when you're reducing. We can see that we have an addition problem, but our denominators are not the same. So we're going to have to do some factoring here. And I don't see any perfect squares, so sum and product is the way to go here. Sum and product for this first denominator. In the middle, we've got a minus 9 for the sum. 1 times 18 would be 18 for that product. So what makes 18? 2 times 9, and both of these would need to be negative in order to have a negative sum. But negative 2 plus negative 9 is not going to make negative 9. So try some other factors. 6 times 3 makes 18 if I make them both negative. then sure enough, when I add them up, I am going to have negative 9. So this denominator is going to be x squared minus 6x minus 3x plus 18. And I've got 4 terms, so I know to use grouping here. We have x in common, leaving x minus 6. So x minus 6 has to be in the second group. Filling in that gap, I'm trying to match minus 3x, so a negative 3 is needed. My common factor becomes x minus 6, and that other factor is x minus 3. So I can rewrite the first term in this addition as 4 over quantity x minus 6, x minus 3. The second rational expression needs a sum and product. Sum is minus 5. Product, 1 times negative 6 is negative 6. So 1 times negative 6 would make the right product, and 1 plus negative 6 will give us the correct sum. So our replacement, we have x squared plus x minus 6x minus 6. This creates our 4 terms for grouping. In the first group, x is in common, leaving x plus 1. So x plus 1 must appear in that second group. Thinking in the gap, create negative 6x squared with a minus 6. So our common factor is x plus 1. The other factor comes from x minus 6. Okay, so now what I can do, I'm trying to create that lowest common denominator, and that's going to come from the unique factors. So I'm just going to go across the board here. I'm going to highlight factors we came up with. So the first one, x minus 6, we need that. It's our first factor. Of course, it's unique. The next factor, quantity x minus 3. Well, that's different, so it's unique. We need that one. Our next factor, quantity x plus 1. That's unique. Quantity x minus 6. We already have that one written, so we don't write it again. Both are raised to power of 1. So all 3 of these quantities are the lowest common denominator. So our first term, remember we rewrote that one already. It has these 2 quantities, so I have to build up with the one that's missing. It looks like quantity x plus 1 is the missing quantity. Then we have addition. So our second term here, we have 3 in the numerator. Our denominator, remember how it factored? Quantity x plus 1, quantity x minus 6. Multiply by the factor that is missing to build it up. So I have quantity x plus 1 and x minus 6, so it looks like we need quantity x minus 3. So now you can see both of these denominators have the same 3 factors. So we've got quantity x minus 6, quantity x minus 3, quantity x plus 1. Again, it doesn't matter what order you write them in as long as you have all 3. In our numerator, 4 is distributed to this quantity, making 4x plus 4. It is addition, so it's positive 3 distributed to each of these terms. Positive 3x minus 9. So if we have any like terms, they need to be combined. I've got 4x plus 3x, that would be 7x. 4 take away 9, that would be minus 5. And our denominator is x minus 6 times x minus 3 times quantity x plus 1. Since 7x minus 5 doesn't have any common factor, this would be our final answer. So in our last example today, we have a squared over a minus 4 added to 16 over 4 minus a. Now you'll notice that these denominators are in the reverse order of each other. So if I factored out a negative 1, remember that changes the order of the terms. So I could see that my LCD involves the factor negative 1 and quantity 4 minus a. So I'm rewriting my first term, a squared over negative 1 times 4 minus a, added to my second term, which is 16 over 4 minus a. And comparing that with the LCD, I can see that negative 1 is the missing factor. So I have to build up with that missing factor of negative 1. So now in the denominator, I have a common denominator of negative 1 times the quantity 4 minus a. I have a squared as the first term. And 16 times negative 1 would be minus 16. Do you recognize a squared minus 16? As a difference of squares, we could write that as a plus 4 times a minus 4. Now if I rewrite this denominator, so when I rewrite the denominator, I'm going to distribute that negative 1 so that I can look for an opportunity to reduce. That would give me negative 4 plus a. Well, that's the same thing as a minus 4. So it might be a better way to write that denominator. And now we can see that the quantities of a minus 4 reduce, and all we're left with in the numerator is a plus 4. And that is our final answer. Since it is all collected in the numerator, we're not going to have a rational expression for the answer.